In this video, we're going to discuss first two questions of question paper 2-1 of 9701 Chemistry Examination Series, October-November 2024. And if you want to get access to lots of resources at a very cheap rate for IGCSE chemistry, log on to the description or the website which is shown here and download the app at a very low cost. So now let's start with the question 1 of question paper 2-1 of 9701 chemistry, that is AS level chemistry of the examination series winter 24. And here is question 1, which says cobalt, rhodium and iridium are metals in the same group of the periodic table. The shorthand electronic configuration of cobalt is shown here. Identify what is meant by this bracket AR, which is given here by giving its full electronic configuration. Now AR is argon element, which is written in short here, and that shows that till argon the electronic configuration is not mentioned and written as a short given here with this symbol. So what is the full electronic configuration of argon? Now this shows that the electronic shells which is before 4s and 3d are fully filled, and also we know that the atomic number of argon is 18, so that has to be occupied in the shells which is before 3d and 4s. So let's start with the first one, that is 1s, that is 1s2, then 2s2, then 2p6, then 3s2, and then 3p6. That's what is fully filled till argon. You can count that there are 18 electrons that is here in all these shells orbitals. So that's how you can write the full electronic configuration of argon. Now let's go ahead with the second part, which says the lowest energy electrons in cobalt are in 1s orbital. Draw the shape of 1s orbital. Now 1s orbital, we know it's a spherical orbital, that is 1s. Draw a proper sphere as not drawn by me, but yes, let me try to correct it. So yes, this is how you can draw a sphere which is a 1s orbital. Now let's see what is the next part. Yes, deduce the number of unpaired electrons in a cobalt atom. Now let's see here, we can see that till argon all the orbitals are fully filled, that is they have paired electrons. In 4s also you can see it is paired because there are 2 electrons. Now what is left is 3d7. Now if we work out the electronic configuration of 3d7, we know that the d shell, that is d orbital, have 5 orbitals, that is suborbitals, and if we fill all these 5 orbitals with 7 electrons, then we should first singly fill all the 5 orbitals, and then the leftover 2 electrons we fill like this. So remember, all the orbitals of d has to be singly filled first and then the pairing starts. So if we have 7 electrons in the 3d orbital, this is how it's going to be this way, pair electrons, and we can see that there are 3 electrons which are unpaired. So we can write there are 3 electrons which are unpaired in the 3d or you can say in the cobalt atom. Now the B question is table 1.1 gives some details of a stable naturally occurring isotopes of rhodium and iridium. Now here are given the isotopes of rhodium and iridium. Number of protons is the atomic number by default, so we don't have to think much, just write the atomic number of both the rhodium and iridium. Now number of neutrons is something which you have to find by subtracting these two numbers, and that is going to be 114 for iridium, because if you subtract 191 minus 77 you get 114, and here you get 116. Now total number of electron shells here. Now to see total number of electron shells, we need to look at the position of rhodium in the periodic table, and let's have a look into the periodic table given here at the end of the question paper. Yes, here is the periodic table. Yes, in this periodic table we can see that the rhodium is here. Now if we want to count the number of total shells, shells is a principal quantum number. So we can see here period 1, period 2, period 3, period 4 and period 5. So if it has 5 periods, it should have total of 5 shells. So rhodium is having total of 5 electronic shells. Yes, so let's write that here. In total number of electron shells are 5. So this is how you're going to complete table 1.1 by filling up all the gaps given here. The next part is table 1.2, that's given here, shows the relative abundances of the isotopes in a sample of an alloy containing rhodium and iridium only. Okay, so we have an alloy containing only the two metals, that is rhodium and iridium, and here are the relative isotopic mass and the abundance given in the alloy. So we can see that 50% of the alloy contains only rhodium and the remaining 50% is iridium. Only remaining 50% is iridium. The first 50% you can say is rhodium. Now here the first sub question is define relative isotopic mass. Now we need to understand that it is relative isotopic mass. So how are we going to define is that it is the mass, it is the mass of an atom, mass of an atom of an isotope, compared to carbon 12, which has a mass of exactly 12 units. Okay, so here it is compared. Relative is something in comparison with. So if an isotopic mass of an atom of an element is compared to what? It is compared to carbon 12, which has mass of exactly 12 units, and that's how it is compared relative. Okay, the second part is use table 1.2 to calculate the relative atomic mass AR of iridium in the alloy. Now understand, it's only iridium in the alloy. Give your answer to 2 decimal places. Remember, it is 2 decimal places. You are supposed to calculate the relative atomic mass of iridium only in the alloy only. Now we can know that here are the iridium with the isotopic mass of 190. So the first isotopic mass is 190.96. that has to be multiplied by its abundance. Now its abundance is 15.18. So here multiply the mass with its abundance. Okay, now add another iridium isotopic mass and its multiplication. So here we have 192.96 multiplied by its relative atomic mass, abundance, which is 34.82. Yes, and then divide it by its total percentage. Now percentage of iridium is 50% because the remaining 50% is rhodium. So divide by 50. So that's how you're going to calculate the relative atomic mass of iridium here in the alloy, and we have come up with the answer as 192.35. that's the relative atomic mass of iridium in the alloy to 2 decimal place. Remember, so this is 2 decimal place. We are ending up writing with it. So let's write it here in the blank, 192.35. yes, let's go ahead. Okay, the D, it's hydrated rhodium 3 chloride given here catalyzes the conversion of ethene to but2-ene. Now both stereoisomers of but2-ene are formed in the reaction here. So remember, both these stereoisomers of but2-ene is formed. Hydrated rhodium 3 chloride contains 20.5% by mass of water of crystallization, that is XH2O. Now deduce the integer value of X in this compound, that is rhodium 3 chloride hydrated. Now show your working. Now it's given that the hydrated water part is 20.5%. So how are you going to show? Only water is 20.5%. So what is the mass of the water? We don't know what's the value of X, but we know that the mass of water is 18. If there are X molecules of water, then 18 has to be multiplied by X. So we have 18 into X, right? Now divide by the total mass of the whole compound. Okay, so total mass of the whole compound, so how are we going to write is that the mass of the rhodium is 102.9 as given, plus chlorine. So there are 3 chlorine atoms, so we have to multiply it by 3. So what's the mass of chlorine? 35.5. So that's what we are totaling up for rhodium 3 chloride plus water also, and we know that water is 18x. Now this has to be multiplied by 100 to get the percentage, and we know that the percentage is 20.5. that's given here in the question. So this is how we find out the percentage, and that's we have applied. Now if you work out the value of X here, the value of X, we end up with 3. So this is how you're going to, you can just feed it in the calculator and you will get it. Value of X, we end up with 3. So the value of X in water as in whole integer is a 3, right? Yes. So now the next part is define stereoisomers. Now isomers, we know they are the compounds with the same molecular mass but different structure. Now the question is stereoisomers. So what are stereoisomers? So they are the molecules which is having same structural formula, but different spatial arrangement of atoms or groups. Now let me explain what is this. The isomers, which we already know what's the definition of isomer, that they have same molecular formula but different structures are called isomers. Now what are stereoisomers? Stereoisomers, they have same structural formula. Structural formula is also same. What's the difference is the arrangement of atoms in the space, that is in 3D manner the atoms are arranged in different way, that is maybe an atom is first arranged downside but in the next isomer it is arranged upside, or it can have the mirror image of each other. So that's how we define stereoisomers. Now part 3, explain how conversion of ethene to butene can be described as an addition reaction. Now you know ethene is just doubling to butene. Now you can know that the ethene have 2 carbon atom but butene have 4 carbon atoms, so it's just doubling. So we know that it's an addition reaction, but how can we prove that? So for any addition reaction the product is only 1. So we can say that the product formed is only one product, or you can say only one product is formed. So this is how an addition reaction can be described, because in addition reaction there won't be any byproduct. Now it says draw the 2 stereoisomers of butene. Now let's first understand what is butene. Butene, first I'll draw the structure of butene in a simple way. Now the 2 in means on the second carbon you have a double bond. So yes, between the second and third carbon we have a double bond. Now remaining will be hydrogen on each carbon. So here there is 1 hydrogen each, and here, yes, there are 3 hydrogen on the last carbon. Now if we want to draw the stereoisomers of butene, obviously if we have one double bond here, it's going to form geometric isomers. Geometric isomers are also named as cis and trans isomers. Now what are cis and trans isomers? Cis isomers are the isomers which have the similar group on one side. Now here if we draw the two carbon carrying the double bond, this carbon have one hydrogen and the other group as CH3. So I'm drawing one hydrogen and the other group as CH3. Yes. Now this second carbon atom, also have one H and one CH3 bonded to this second carbon atom. So that is again one H and one CH3. Now if these CH3 groups are on the same side and again the hydrogen is on the similar side, so that is cis isomer. So this is cis butene. Now what is trans? When these groups are on opposite sides, so here we have two hydrogen on opposite side and CH3 group also on the opposite side, then this is trans butene. So this is how you're going to draw the stereoisomers of butene. Let's go ahead with the next question. And this is question 2. Now let's see, it's all based on chlorine and group 17. So chlorine is one of the elements in group 17 of the periodic table. Now the first question A, that is sub question, is describe the colors of the group 17 elements chlorine to iodine at room temperature. So what are the colors of the elements of group 17? That is chlorine. Chlorine is actually yellowish green gas, but you can say green color or light green color. So chlorine is green color. Then next comes bromine, which is a red brown liquid at room temperature, and then comes iodine, that is gray black solid at room temperature. So that's what we are writing the colors. We are not writing the state because they haven't asked about the state. We are just writing about the colors. The next part is describe the relative reactivity of the elements chlorine to iodine as an oxidizing agent. Okay, now let's remember what is an oxidizing agent. Oxidizing agent is a one which allows the other element to lose the electron and itself gains the electron. So if we talk about the oxidizing agent, fluorine is the best oxidizing agent because it accepts electrons very easily. So if we are talking about chlorine to iodine, the oxidizing capacity, that is oxidizing strength, you can say oxidizing strength or capacity also can be written, decreases from chlorine to iodine. That's what we can write, because fluorine is most oxidizing and then comes chlorine and then bromine and then iodine. It decreases down the group, so we can write it this way. The third part is state what is observed when chlorine reacts with hydrogen. Now if chlorine is reacting with hydrogen, HCl gas is obviously formed. So the thing is that chlorine is a green gas, hydrogen is colorless gas, and even HCl is a colorless gas. So what you can observe is that chlorine is getting used up. So we can say that green color disappears, or you can say green color fades. So here we can say disappears or green color fades. So anyways, it's acceptable. Now let's see what's next, the fourth part. Okay, explain why the thermal stability of hydrogen halides decreases down the group. Now when we talk about hydrogen halides, it's like HF, HCl, HBr. So in short, we can write as HX. Now what happens to the thermal stability? It decreases down the group. That shows that the hydrogen iodide can easily be decomposed or broken down to its elements compared to HF. HF, that is hydrogen fluoride, is difficult to break down or difficult to change it into elements, so it decreases. Now what's the reason? The reason is that the covalent bond gets less stronger, the covalent bond becomes weaker. So if HI bond is weaker, then I and hydrogen, that is iodine and hydrogen will decompose very easily. So we can write that HX bond becomes weaker down the group, and the reason is that the atomic size, or you can say the ionic size of the halide increases. So you can say as atomic size increases down the group, that's what we can write the reason here, because they have said explain. So we have already given one reason, that HX bond, that is covalent bond, becomes weaker, but then we are explaining one more point. Maybe because it's just 1 mark, the second point is not required, but as we have the space, so to be on the safer side we can write. Okay, so B is the next sub question. The halogenalkane forms when chlorine reacts with ethane, this is ethane, C2H6, via a free radical substitution mechanism. So this is chloroethane forms from chlorine and ethane. Define free radical. Now here they said free radical substitution reaction. So what do you mean by free radical? Now here chlorine is going to act as a free radical in this reaction during the mechanism. So what is free radical? Free radical, it is a species or an atom or a group of atoms. So I'm just writing species in common because it can be an atom or a group of atoms or a molecule. So it is a species which have at least one unpaired electron. So as the electron is unpaired, it can react very easily to gain one more electron, and that's why free radicals are very reactive. So we can write that they are the species which has at least one unpaired electron. Now state the essential condition for the chlorine to react with the ethane at room temperature. So what is required is the sunlight, or even you can say UV light is required to react at room temperature for these two reactants to form chloroethane. Okay, the third part is write two equations to show the propagation steps in this reaction. Now remember, they are asking for the propagation steps, so we don't need to write the initiation step where the free radical of chlorine is formed. We have to directly write the propagation step where chlorine radical reacts further with ethane. So now ethane is CH3 I'm writing. Now this chlorine radical is going to react with the ethane to form HCl as a byproduct, and so if HCl is formed, it's going to knock out one hydrogen from ethane. So what is left is CH3 CH2 free radical. Now this is the propagation reaction. So for this free radical, that is the free radical of ethane, is going to react with the chlorine to form CH3 CH2 Cl, and one more chlorine free radical is going to be formed here. Now in few of the textbooks or internet, you may find that the free radical dot can be written in front also, so that is also acceptable. You can write it in front, not on the top, that is fine. Now if we go ahead, it says CH3 is another halogenalkane forms when propanol reacts with the sodium chlorate, that is NaClO, that is sodium chlorate 1. So trichloromethane is here, CHCl3, that is formed when propanone reacts. Now what is propanone? CH3COCH3 is propanone, and that reacts with the sodium chlorate. Now sodium chlorate is made from chlorine in a disproportionation reaction. Identify a reagent and conditions that can be used to convert chlorine to NaClO. Now they have already said that chlorine is reacting with a reagent to in a disproportionation reaction to form NaClO. So chlorine should react with what reagent to form this product? So the reagent which reacts with the chlorine to form NaClO is the cold NaOH, cold sodium hydroxide. If we use hot, it's going to form sodium chlorate 5, NaClO3, which we don't want. So cold NaOH, remember cold is necessary. The next part is define disproportionation. Now what is disproportionation? As it's written here, in a disproportionation reaction. Now what is that reaction? It is the reaction in which a species is both oxidized and reduced together, means it forms a product where the species is oxidized. It forms another product where the species is reduced also. So you can write it this way, that a reaction in which one species itself undergoes both oxidation and reduction together. And let's see what's next question. Yes, the third part, here it says write numbers in the boxes to balance the equation. Now you're going to balance this equation which is shown here, where the reaction of propanone with NaCl is shown. Here is propanone reacting with sodium chlorate to form trichloromethane, sodium ethanoate and NaOH. Now we know that the chlorine is 3 here, so 3 chlorine atoms are required, so at least try writing 3 here to balance it. Now we know that the propanone is only one molecule used, so here also it should be 1, because we can have the CH3CO only once and 1 carbon already used up here. So there are 3 carbon all shown here with 1 propanone molecule. So 3 carbon of the propanone and 3 carbon on the product side is already balanced. Chlorine we have already balanced. Now what is left is sodium and oxygen, which is 3 on the reactant side. So here we have already 1 sodium, so we can balance the remaining 2 sodium by adding 2 with NaOH. Okay, oxygen here is 3, so 2 oxygen here and 2 oxygen here, 4, and we know there is 1 more oxygen on the reactant side, so total reactant side have 4 oxygen and the product side also have 4 oxygen. Hydrogen is 2 on the product side, and there are 1 more hydrogen and 3 more hydrogen, so 1 plus 3 plus 2, so total of 6 hydrogen on the product side, and here also we have 3 plus 3, 6 hydrogen on the reactant side. So hydrogen also balanced. So the reaction is balanced now, that is 1, 3, 1, 1 and 2. The fourth question, sub question, and the last one is aqueous silver nitrate AgNO3 dissolved in ethanol reacts with the aqueous solution of trichloromethane CHCl3. State what is observed in this reaction and explain your answer. Explain means we need to give the reason, and state what is observed, so we need to write the observation. Now if silver nitrate is reacting with any compound containing chlorine, it's going to form the white precipitates. White precipitates are seen because AgCl is formed. So as AgCl is formed as precipitates, And why it is formed as precipitates? Because silver chloride is insoluble, or you can say very sparingly soluble in the aqueous form. Now this question carries 2 marks, so we have given the observation and the reason, but as we have the space and we can explain more, I prefer explaining more. So what else we can write is that CHCl3, that is CHCl3 is also hydrolyzed. Now in hydrolysis, what is formed is methanoic acid is formed, so that we are not writing because it's not seen as an observation. The observation white precipitates is because of AgCl form. So but as we know, CHCl3 is hydrolyzed, so I'm writing it here. So this is what you're expected to write in 2 marks, that is 2 valid points, 1 observation and 1 explanation is given. So here question 2 also ends. In our next video we're going to discuss question 3 and question 4 of the same paper.